All right, now what about a random sample of 750 drivers again? What is the probability that less than 728 of them will be speeding? Okay. But here's the thing. With these last two, I gave you, well, this one I gave you an area right out. And this one I gave you a percentage. See it right there? But for the one we're looking at right now, I didn't give you a percentage. So you're going to have to come up with a proportion on your own, right? But luckily we know the formula for that. P hat is x over n. So we're going to use that formula right here. There we go. So 728 is not a proportion, not a percent. Percent, proportion, whatever you want to say. So we're going to have to turn it into one, right? And to do that, we'll use the p hat equals x over n formula. So you grab your calculator and you take, okay, clear, 728 divided by 750, and we get 0.9706 repeating. And so that's where that came from right there. Okay, so now we're going to use normal CDF, just like before. Now why? Well, because it asks for a probability. See the word? What is the probability right there? So if we look at the decision matrix, when it's asking for a probability, that means, right here, if you want a probability, green, you're going to have to use normal CDF. So that's what we'll use. We'll use a normal CDF. Oh, there's the problem right there. Normal CDF from negative 1E99 because it's a less than problem. So we've shaded to the left here. Right there. So we're shading right there to the left, 0.9706 repeating, shade to the left of it, and now we need to find that area. So I'm going to grab my calculator again. I'm going to do normal CDF, so number 2, negative 1E99, that's great, 0. Actually, if I do this, I'm going to lose accuracy. I'm actually going to type the fraction, 728 divided by 750. That way I won't be stuck typing 66666 at the end of that problem. 0.98 again, and then again the square root 0.98 parentheses 1 minus 0.98 divided by 750. There we go. Enter. And I get 0.0339. And again, notice that fraction, you can put it right in the formula. That's why I wrote it right here. 728 over 750. You don't have to separate it. You can actually make it part of the problem. All right, now would finding that that small a number of speeders, there we go, finding less than 728 of cars speeding be unusual? Yes, definitely, right? Because the probability of less than 728 is equal to 0.0339, which is smaller than 0.05. Right? Remember, unusual to us means less than 0.05, less than 5%. Remember that back from, we first learned that in chapter 3. All right, so then if you do have it happen, if your sample has this occur, what are the possible outcomes? What could be happening? Well, there's three main reasons we could explain, and we have to explain each one of them. So one is it could just be a biased sample. That's usually the one students picked up on in class. They'll say, oh, the radar gun was broken, the car wasn't really invisible, people could see the cops, people knew they were doing this, whatever, right? So for some reason your sample was biased, right? And so there's an explanation. So you would explain, not all three of them, but give yourself an explanation for how it could be biased. All right, then it could just be a fluke, right? It is possible to just have a sample that didn't have very many speeders, right? That would be by random chance, we just had a slow group, but the probability of that is 0.0339. So you have to determine, I think that's kind of low. Maybe something else is going on. So if it isn't that they could see us with the radar gun. And it isn't just a fluke. That leaves us one other option. All of this was predicated, right, built on the fact that we said we had a sample of 750 and a p-value of 0.98, right here at the very beginning. So we said, hey, our parameters are, well, the p in particular is 0.98. Sample size is not a parameter, but bear with me. So p is 0.98. That's what we said. But maybe we were wrong. I mean, if it's off by just a little bit, that'll send everything else into a tailspin. So it's possible that p equals 0.98 is just not correct anymore. Maybe it was never correct to begin with. Who knows? Because we don't really know where that came from or what to say about it, right? And that last bit right there is what we're going to be working on in the next chapters, right? So this is how you start, quote, proving people are lying, end quote. We never really prove it, but we start making arguments that are in support or contradict people's beliefs, suppositions, right? So we'll make hypotheses and say, okay, I think it's 98%, and then we'll go test it. And if we don't get 98% of the people speeding, that's kind of a sign that something else is going on here. And so that's what we're going to be working on from chapter 9 and beyond, is this parameter that we assumed the 0.98 was not actually correct in the first place. All right, we're all done with chapter 8. I'll see you back here for more lecture videos in a later chapter.